Namaskar, everyone. Can you see my screen? Can you see my screen?
Yes, yes.
Okay, so this
It
is
is
a
written memory.
yes, that's right. So I think we talked about this, and we decided to go ahead to just talk about cerebral memory and not extracerebral memory. That probably is a much longer topic, and this would kind of be a 2-point presentation in correspondence to what Dr. Ashu spoke about yesterday. So I would just be talking about the pathology, and she spoke about the remedies that Shri P.R. Sarkar has talked about, natural remedies. So I would be talking about sort of pathology, what happens with cognitive impairment. Um, so if you have any questions, feel free to chat it. I'm going to talk about this for I think I have to finish at 6:40. I'll just talk for 20 minutes, and then we should have 20 more minutes. We should have 10 minutes for questions. I'm happy to take them. So quickly, what is memory? What is cognition, right? So memory strictly is the mind's ability to receive, process, and replicate whatever information you've seen or heard or tasted or sensed, something that your sense organ takes in and your mind stores, processes, and you're able to replicate it. What's cognition? So cognition is different than memory, right? Cognition has many functions. It's memory, but it's also executive functioning. So cognition is when you wake up in the morning, you know you have to go to work, you wake up an hour earlier, you plan your day in such a way, I don't know, you pack your lunch, you brush, you take a shower, you prioritize which activity is more important, you decide what you're going to do and how much time a certain activity takes, and then you do it in such a way that you're able to go to work in 40 minutes, right? Or you wake up, depending on what it is. So it could be executive planning, it could be your ability to process information and have options, right? So for example, someone says, well, I don't think this is a good topic to discuss right now. It could mean they're saying that this is not a good topic to discuss right now, or that they're actually saying that's not a good topic, and they're just using a euphemism. So cognition is intelligence too, right? Ability to take a topic and ascribe many meanings to it. So there are two different things. I will be focusing on just memory. So memory is your ability to remember things, right? Basically, that's what it is. So what kinds of memory exist? Sorry, let me just quickly grab this. Can you see the screen? I'm going to proceed. If you can't, please let me know. So there's
a little bit clearer.
What is it not clear? Okay, so just give me a second. Let me see if I can do anything about it.
You can click on your green circle in the left. Yeah, okay. Now
is this any better? Is it better?
It's better.
Yeah, sorry. I'm sorry. It's a little blurred. It's not I apologize. It's not the greatest presentation, but I will talk about it. So there's two kinds of memory, right? The commonly heard definition when people say, oh, my long-term memory is fine. I remember what happened in the past, but my short-term memory is not great. So short-term memory and long-term memory. Another way of dividing memory, which is pretty much what scientists usually do, is declarative memory and non-declarative memory. Declarative memory is memory that people can see. The memory that we look at people and judge. If someone says something, we look at it, we listen to it and say, oh, he has a good memory. And there are some things we can't see, but that's also a part of memory. Let's talk about the memory that we can see, right? Declarative memory. So there are two kinds of declarative memory. Declarative memory is really just that, the memory that you show, that memory that's tangible, memory that people understand. So there's two kinds. One is semantics, which is really what the word says, right? Like when we say semantics, when someone uses different words for a particular word, we say, oh, that's just semantics. So semantic memory, it is just that. It's learned memory. It's stuff like, oh, Berlin is the capital of Germany. The president in America is elected on the 8th of November. Is that the right date? These are things we know because we've heard about them, we've read them, we've been told about them, and our brain just has to process it and store it and then regurgitate it. So general knowledge, facts, meanings of certain words, and these these are things we go to school to learn, right? Like it could be trigonometry, geometry, arithmetic. You don't need to be personally associated with this memory. This memory is devoid of any context. And this memory is really solid, right? Like Delhi is the capital of New Delhi is the capital of India. You take it in a different context, it doesn't mean much. It's still the same. You can say that if you said it 20 years ago, that would still be the same, and currently it's still the same. It doesn't change much depending on the context. So semantic memory is just memory that you learn and you store. And then there's another kind of declarative memory, which is episodic memory. This is the kind of memory you experience. These are episodes of personal life, your birthday, your son's birthdays, where did you go to holiday 2 years ago, if there was something, if you experienced something shocking or fun or emotional during that holiday, then your amygdala tags it and you remember that. It's episodic. It's not something that someone taught you. It is something that you experienced and then you store it. So these are declarative memory. And so usually when people talk about, when people talk about the politics of Israel and Palestine, or when they talk about conflict in Kashmir, or they give you nuance about the electoral system of the world, that's semantic memory, right? Then we say, oh, this person has good memory, like he remembers everything. Or they're able to tell you what happened 20 years ago in their life, or they're able to tell you exactly what happened in that conversation with their wife 2 years ago. Then we say, oh, this person has a great memory. He remembers everything. He has a photographic memory, right? So that's declarative memory. Non-declarative memory, on the other hand, is the memory that people can't see. There's three kinds. One is procedural memory. This is memory that you learn because you do it repeatedly, right? Like cooking could be an art, but it could be a skill. Like when you first start cooking, you need a book, you need to find out the exact recipe. But once you do it, it's like, olive oil and seasoning, and then your protein in there, or jeera and choke and ginger and curry pata. Like these are not things you need a book for. These are things that your brain has known. And let's say you've had something shocking happen, something not a terrible thing, but like let's say you're watching television. Let's keep things positive in the pandemic. So let's say you're watching television. There's something really interesting you can watch and still cook, right? Like you don't really need to focus if you've done it enough to really cook. You can stir the pot, you can season it, and still focus on something else. So procedural memory is memory that your brain has, it's done this so many times that there are like solid loops that are formed that you don't really need to focus on it then and there. This could include skills such as riding a car, riding a bike, operating a heavy machinery, all these sort of like minor skills we learn. And procedural memory could also include walking, running. These are things we know that people, when they have a stroke, forget, and they have to learn all over again. And they would have to focus on, do I lift my left leg up, right leg up? How do I get my balance, right? Like these are things we know because we've done them a million times. And then there's associative learning. This is complicated learning. This is not something they teach you at school. This is something that life teaches you. If I put my hand in an open socket, I'm gonna get a shock. This is something that babies explore. They try. You're never going to try it again. It's operant conditioning, right? Like you put your hand in there, you're going to get a shock. Any open wires anywhere, they're associated with you getting an electric shock. You're not going to go and try it. That's classic conditioning. Or it's Pavlovian, right? Like Pavlov conducted this experience where he gave it's a little complicated, but they gave the dog a food and they looked at the salivary glands, and then every time there was food, he would ring a bell, and then the dog would eat the food, and it would secrete the saliva, and after some time he would just ring the bell. The bell would ring every time with the food, and then there would be no food. The bell would ring every time with the food, and the salivary glands and the digestive glands would secrete their juices, right? So one thing being associated with another thing repeatedly is something that our mind associate. And I think this is the basis for why most philosophies say satsanga, right? Like going into a good environment is associated with something that is very easy for the mind. So this is non-declarative memory. So classical and operant conditioning, and emotional responses. We see a child being hurt. Somewhere deep down, there's empathy. We've had children, or we've seen children, especially if you have children, then it's strong. You put yourself in that person's shoes and you think, oh, this could be my child. And you have a wizard, like you read something terrible happening to a child somewhere at the borders, and your mind has a visceral response to it. It's not happening to you. Normally people, I mean, if you were to be perfectly rational, you'll say, it's not happening to me. It's happening somewhere, in New Mexico or Arizona. Shouldn't bother me. But it's such an emotional response because we all have empathy. We put ourselves in their shoes, and it could be happening to our children, right? So that's associative learning. And non-associative learning is reflexes. You touch a hot pot, your hand withdraws. You're driving, you see a car come suddenly to your left, and you go the other way. These are reflexes. This is something that you don't put brain. This is not something you learn. This is just something your spinal cord responds to save you. And that's non-associative learning. So non-declarative memory is of three kinds, right? Procedural memory, something you learn by doing it many times. Associative learning, something you learn not by doing it many times, but by doing it, and the punishment or the reward is so high that you don't forget it. And non-associative learning, which is really just something your spinal cord and your brain does to keep you safe. There's also priming and habituation, and then we can talk a little more later if we have time. So these are two kinds of memories. Whereas it's hard to know, memory is a dirty job. It's hard to know where these are processed. But if you can see it on the top, declarative memory, I'm just actually going to go down here so that you can see it. Can you see this? Didi, yes? No?
Yes,
Okay.
that's we can see it.
Yes, we see.
Okay, good. So declarative memory is mostly stored, and you can see my arrow here, right? Can you see my arrow?
Yes, Tapsi.
Okay, it's mostly stored in the medial temporal structure. So this is your brain, right? It's a cross section of brain. If you cut me like this is how you see it. This front part is the frontal lobe because it's in the front, and the back part is occipital lobe. It's in the back. It's occipital because it processes what you see from your eye. It's the occipital lobe, occiput. It's just behind the occiput, and the top part. There's two. This is the parietal lobe, and if you go down here, there's the temporal lobe. So medial temporal structures which are in the middle of the temporal. So these structures store your declarative memory. So mostly it's hippocampus and the folds that are around this place. Hippocampus and things around this place store your declarative memory, right? So your temporal lobe is quite important in storing your declarative memory. The non-declarative memory, like these ones, are a little complicated. So you have limbic system, which is this whole system, basal ganglia, this whole thing, which looks like a reptile, which is why it's called limbic system, because that's a Latin name for that, right? Like, so this structure, and striatum, which is, you can't quite see here. The two parts of your brain are connected by a bunch of fibers called striatum, and then the prefrontal cortex. So this is frontal cortex, which is important. And then the prefrontal cortex, this little thing you see in the front of the frontal cortex. So all of these structures are involved in maintaining your non-declarative memory. So different parts of brain, the takeaway is different parts, and sorry, your cerebellum too. Your cerebellum sort of, it decides how much balance you have, how finely your hand can move. And so because that supports fine movements and fine skills, it also encodes these non-declarative memory. Another interesting thing, I'm just going to move this a little, is how both declarative and non-declarative memory is stored, right? So there's frontal lobe here. You can see this, it's colored here. It's in purple and blue. And then there is parietal lobe, which is in red and this dark blue. And then there's temporal lobe, which is in yellow, and then the occipital lobe, right, which is in the back. So the brain is complex, but to make it very easy, I'm just going to say frontal lobe is a thinking lobe. There's really not much that is relayed there. The back part of the frontal lobe, or you could say the front part of the temporal lobe, this dark blue thing, which says motor area on there, This is a tiny part of the brain which receives all the messages that come from your hands, your legs, and your motor organs, right? Like urinary organs and excretory organs. Sensory area receives all the information that comes from your senses, your tongue and your nose and your eyes and your ears and your skin, this tiny little area. So just beside that, behind the sensory area, there's a little area that stores and processes the information. And in front of motor area, it's called premotor cortex, that stores and processes information that comes through the motor area. So like you touch something, it's hot. This area stores the fact that something that looks like, let's say there's a pan which is red, you have a red colored nonstick pan in your house, you touch it once and it's hot, you burn yourself. That area is going to encode that something that looks red or that's on a stove is going to be hot. You can't touch it. It stores there forever, right? And so in the temporal lobe is where your ear sends all its information there. And in the back of the brain, occipital lobe, is where our visual information is stored. So some of these memories are processed in these places, right? The prefrontal cortex, the medial temporal structures. And then the brain is like, where do I store them? The hippocampus is not a big structure. The middle part of the brain is not huge. So what it does is it's like a secretary that organizes things. So it sends it back to the areas where it came from. So if I see something, then it's gonna file all that visual information in this visual cortex. So if I've seen something, then it goes back and it's stored next to where next to the eye processing area. If I've heard something, then I'll remember it in the hearing processing area. If I felt something, then I will remember it in the sensory area. So like, psychologically, so sometimes you go to a place and I smell something and I just say, it reminds me of my mother when I was young, right? She had a particular perfume. And this is pleasing, right? So that goes to your sensory cortex, it's or your olfactory cortex. It's pleasing and you will always associate this with something nice. So there's this term, it's kind of archaic in psychology, where they say, you marry, you look for and marry someone who's like your father or mother, right? Like there is some sort of a basis to that. Like these smells, these thoughts, these senses that are associated and are either pleasing or not to us, we kind of look for those subconsciously. We crave for those, we look for those, and then when we find that, those parts of our brain get activated. And this is not conscious at all, right? Like consciously we're talking about something else, and there's all this non-verbal communication that's happening that we're just not aware of. And the memory that comes through your motor cortex is filed near your motor cortex. So this is pretty much it. I'm quickly going to talk about cognitive dysfunction. I think there's also somebody else who's going to talk, so I'm not going to do this in detail, but I'm just going to quickly, can you talk about what happens during dementia? So what are dementias? They are neurocognitive degenerative changes. So the brain is complicated, but the basic unit of the brain is a neuron. One neuron is connected to another neuron, and that area of connection is called a synapse, right? So there's millions of synapses in your brain. They connect with each other, they pass messages, there's chemicals in that synapse. And in dementias, the neurons are damaged and the synapses are damaged. So basically, the most common dementia is Alzheimer's dementia. There are many kinds of dementias. When people say, oh, the doctor said we have Alzheimer's, or Alzheimer's, it could be Alzheimer's, but it could also be vascular dementia. It could be frontotemporal dementia. It could be Lewy body. I got the spelling wrong. I apologize. It's LEW, Lewy body dementia. There are many kinds of dementia. So dementia is just degeneration of neurons and synaptic neurons. Alzheimer's is the most common. One of the most common risk factors for Alzheimer's is age. Right, we live longer, so we have more dementias in the Western industrialized countries. So what happens is amyloid is deposited. We normally make beta amyloid protein, but something happens, and this beta amyloid protein is is distorted and it's stored in your brain. It's called AB42. That's the protein that is, and it's stored in your synapses and it damages it. And there are like senile plaques that when you do a biopsy of a person with Alzheimer's when they're getting older, you just have these huge plaques that you can see. And then there's another protein called tau, and there's, it forms these neurofibrillary tangles. All these neurons sort of like tangle into each other. So you have these big senile plaques, which are really dead synapses, and these neurons which are tangled with each other. And so that's what leads to degeneration. And this degeneration happens in temporal area and mostly in the hippocampus, which is this little ball, and amygdala, and the temporal area, which is pretty much where most of your memory is stored. So people with Alzheimer's have problems with memory. Mostly it's declarative memory, the short-term memory, which I said was processed here. So they usually remember what happened when they were a child, but they probably won't remember if they took their medicine today or not. They probably won't remember where they placed their key 2 days ago. And then this, of course, progresses. But in the beginning, they're able to remember non-declarative stuff. They're able to drive a car. They're able to cook. They're able to go into a party and be perfectly reasonable and gracious and and wonderful. So there's that part of memory which is still remaining, and then the short-term memory starts gradually eroding. I think the reason we talked about this was in conjunction with Dr. Ashu's class, where she talks about, so in medicine, really, we don't have much treatments for this. There are undergoing trials with monoclonal antibodies, but the only two we have is treatments we have is acetylcholinesterase inhibitors and Namenda. We found that when there are neurofibrillary tangles, acetylcholine, which is a chemical, which is in the synapses, which connects the brain cells and helps pass messages, is decreased. So we actually give them everything in our body degenerates. Acetylcholine degenerates with the enzyme called acetylcholine esterase, right? Which is self-explanatory. The enzyme that degrades acetylcholine, we block it. So that's how we try to increase acetylcholine. And that has many side effects, right? Because there's acetylcholine in our body. It leads to decreased heart rate. You can have nightmares. Your mood can get affected. You can have nausea. It can lead to weight loss. And it doesn't stop the progression of the disease. It just slows it down a bit, gives you a 6-month advantage maybe. So there are natural ways of fortifying your memory, and there are natural ways of improving your memory, turmeric being one of them, aloe vera gel being one of them. And so that was what was covered in Dr. Ashu's class. If you did not attend it, I would strongly advise you to. The part 2 of this should have been that. I strongly advise you to touch base and then see the video recording. It's 6:34. I'm going to stop here and see if you have any questions for me.